String theory is a modern concept in theoretical physics that suggests everything in the universe is made up of extremely tiny strings that vibrate, twist, and fold. These actions create objects and effects in multiple dimensions, which we ultimately observe on a macroscopic level. To illustrate this idea, imagine you have a beautiful, colorful garden. The reason your garden is so vibrant is that it contains magical strings that no one can see. When these strings vibrate, twist, and turn, they create the vivid colors of your garden. Although you and others cannot see these strings with the naked eye, they are what shape everything in your garden. The concept of string theory is roughly analogous to this explanation. Scientists use the principles of quantum mechanics to explain the behavior of extremely small subatomic particles, such as electrons, while the general relativity describes large-scale events across the universe. However, these two theories do not easily coexist, especially when it comes to gravity. There are four fundamental forces in nature: the weak nuclear force, the strong nuclear force, the electromagnetic force, and the gravitational force. Quantum mechanics can account for the first three forces, but it struggles to explain gravity. This creates a gap between the two theories, leading many scientists to believe that string theory could bridge this gap. String theory is often referred to as the theory of everything because it has the potential to unify the principles of quantum mechanics and general relativity, explaining everything in the universe, from subatomic particles to massive galaxies. String theory has been studied for over 50 years. It first gained attention in 1969 when Italian physicist Gabriele Veneziano formulated the Veneziano amplitude, a formula that describes the scattering of four strings. Interestingly, Veneziano was not trying to introduce a new theory. He was merely describing the physics of subatomic particles like neutrons and protons. However, his formula sparked discussions among scientists and paved the way for a groundbreaking theory that could potentially unify general relativity and quantum mechanics. The growing interest from the scientific community propelled string theory to the forefront of physics research, and today, thousands of physicists around the world are still investigating it. At its core, string theory posits that elementary particles, such as quarks and electrons, are not tiny points in space, but rather minuscule vibrating strings of energy. The specific way these strings vibrate, twist, and turn determines the types of particles they produce, such as electrons, quarks, and atoms, which make up everything around us. To explain how this works, string theory makes an important assumption. While our classical world operates in four dimensions, three spatial dimensions and one of time, the theory suggests that we exist in a universe with either 9, 10, or even 25 dimensions of space. Moreover, these additional dimensions are so tightly curled up that we do not perceive them directly. String theory is a compelling concept, but as of now, it remains purely theoretical, with no concrete experimental evidence to support it. Some researchers liken string theory to trying to guess the story of an unopened book based solely on its cover and shape. A significant part of the scientific community critiques this theory due to its fantastical assumptions and lack of experimental validation. Nevertheless, string theory possesses an elegance that appeals to many physicists worldwide. Researchers continue to seek experimental evidence, particularly using the Large Hadron Collider, the world's most powerful particle accelerator, capable of exploring energy ranges that we previously thought impossible. Many string theorists are hopeful that studying subatomic particle collisions may eventually provide evidence to support string theory. Who knows, a few decades in the future, this could become the predominant theory, and it might turn out that everything around us, including ourselves, is composed of vibrating strings.